let's go right back into section 7.2 with a send-off by KISS and look at symmetry with respect to polar graphs. Now, I'm not going to do a bunch with this, but I'm going to show you enough that will help you when you're graphing, because if you know that you have symmetry with respect to a line or a point, you really only have to graph part of the original graph, and then the rest of it comes from symmetry. Now, I've got three drawings here. I've got a drawing here where we have symmetry with respect to what looks like the y-axis, but it's the line theta equals pi over 2. Then we have symmetry which looks like with respect to the x-axis, but that's the polar axis, that's theta equals 0. And then we have symmetry with respect to what looks like the origin, but we're not referring to this as the origin on polar graphs, this is the pole. You can find symmetry kind of like with respect to polar equations, kind of like we did with rectangular equations, by making substitutions and seeing if we get back to the original. So for symmetry with respect to the line theta equals pi over 2, we replace r theta by r pi minus theta. For symmetry with respect to the polar axis, we replace r theta with r opposite of theta, and for with respect to the pole, we replace r theta with the opposite of r theta. So here's an example of kind of a weird one here. I just wanted to point out in that when I use this one and I check for symmetry, I say be careful, because if I check to see if it's symmetric to the polar axis by plugging in r opposite of theta, right in here for r for theta, I get, and then I remember that sign is an odd function, so I can bring the negative out in front, and I get this guy here, which doesn't look like the same as this. But because of the polar distances and some symmetry, or some the effect of what happens with our graph being an odd function, we actually do have symmetry. There's a way to show it, but it's a little complicated. And tell you off the top of my head, I don't know if I remember all the steps. So for right now, what we're going to do is we're going to just say beware when you're graphing. You should be able to see the symmetry pop up. And speaking of graphing, I want to graph r equals 3 plus 3, the sine of theta. Now, I've already created a table of values here. And notice I already have my approximations in here, so that it'll make it easier for graphing. For example, if I was to plug 2 pi over 3 in, the sine of 2 pi over 3 is the square root of 3 over 2, which is about 0.866 times 3, be about 2.4 plus 3, that's my 5.4. So I've gone through all these to kind of save some time. This is really the most time-consuming part of the graph, is that if I list all these points here, it takes a while. But if I check for symmetry, and I believe this one we have symmetry with respect to the line theta equals pi over 2. So I'm going to replace r theta with r sine minus pi minus theta, so that would give me, I'm checking for symmetry here, r equals 3 plus 3 sine of pi minus theta, which is r equals 3 plus 3, the sine, that'd be the sine of pi, sine of theta, minus cosine of pi, oh, good lord, almost did the wrong one, cosine of theta, cosine of pi, sine of theta. Yeah, if you don't use the right identity for the difference here. Now the sine of pi is 0, so all this disappears, and the cosine of pi is negative 1. So I have minus a negative 1, that's positive 1. So I have r equals 3 plus 3 times all of this turns out to be just the sine of theta. And I get right back to where I started. So I have symmetry with respect to the line, theta equals pi over 2. Alright, so what happens here, and I think you can see this, is that here's pi over 2. Look at the symmetry. The further you get away, these values match up. And as it turns out, I wouldn't have to graph or create all this table. I would just mostly need to go between these values down here and these values up here, kind of like between negative pi over 2 and pi over 2. Now, of course, these are not negatives, but they're coterminals of the negatives. So I'm going to go ahead and grab a graph paper. That's going to take a second. Oh, didn't realize math was so strenuous here. All right. Looks like I left a point there again. Now my biggest value is 6 here, so I think I'm going to make my scale for the first circle here a 1. That way, because it goes out to 9, I think I'll be okay here. I should be able to get a halfway decent looking graph. Now, what I'm going to do to kind of emphasize this symmetry theme is I'm going to graph these points here, and then I'm going to graph these points here, and then I'm going to look at the graph and I'm going to predict what the rest of the graph is. Then I'm going to graph all this in here. Okay, so I'm going to graph 3, 0. Let's see, it'd be right here. I'm going to graph 4.5 pi over 6, 4.5. I'm going to graph 5.1 pi over 4. Let's see, losing track already. 1, 2, 3, 4, 5.1. I'm going to graph 5.4 pi over 3. I'm going to graph 6 pi over 2. Right up here. Now I have part of my graph here. I wonder what the rest of this part down here is going to give me. Now I know this is going to throw off my orientation as far as connecting the dots, but I'll come into play here and you'll be able to see this soon enough. If I graph 3 pi over 2, of course anytime the r is 0, you're at the pole. And then 5 pi over 3, that's this way. It's 0.6, so I'm really going to have to be careful here. And then I have 0.97 pi over 4. I have 1.5 and 11 pi over 6. 1.5, gotta find my spot here, and 11 pi over 6, 1.5, and then I'm back up to here. Now, I know this isn't following the orientation, but look what I'm going to get here. I predict that the rest of my graph is going to be over here, symmetric to this line. It's going to kind of look like a fan or something there, a little bit, or at least the top part of a fan. If I go ahead, I'm going to graph this other part here in a different color. I'll use pink so we can see it a little bit easier. 2 pi over 3, 5 pi, 5.4, 5.1, 4.5, 3, 1.5, 0.9, 0.6, and then I'm back to here. Do you see the rest of my graph? And I'm going to try to do this halfway decent in pink. I hope this comes off. Otherwise I'm stuck with a pink graph there. Do you see the symmetry now? I hope. Even though it's, I mean I can see it on my screen, so hopefully you can see it on the screen. Do you see the symmetry? And I was really only having to graph a certain number of points. I went ahead and graphed them all. It's good practice when you're first doing these anyway, to graph the entire set. So we'll look at some more different kinds of graphs and ways to make sure that we pick the right values of theta so that we get a good representation of the graph.